Welcome to Agam's lecture series, a series of lectures designed to bring learning to the comfort of your homes. We are continuing with the chemistry aspect of General Laboratory Technology, GLT 111, Part 2. And we are going to look at the topic today, mixtures, methods of separation of mixtures, and chemical analysis. What is a mixture? A mixture is a substance made by a combination of two or more different sample materials in varying proportions without a chemical reaction. Take it again. A mixture is a substance made by a combination of two or more different materials or two or more different material samples in varying proportions. That means the proportion is not constant without a chemical reaction. Therefore, is a physical process. What are the methods of separation of mixtures? There are so many methods of separation of mixtures, like precipitation. When you have a reaction of two solvents, one is heavier and one is lighter. The heavier one sinks to the bottom of the flask and the lighter one stays on top. That's the method of precipitation. In chemistry, you always like PPT, that a substance is precipitated, thrown down to the base of the textbook. Extraction. When there is a solid material in a liquid material, you can separate them by means of what? Extraction. Filtration. One insoluble solid in a liquid form, you use a filter paper, filter out the insoluble form, and the liquid one will be separated from it. Filtration. Ion exchange. This is used in water purification to remove solid ions in a body of what? Water. Adsorption. Absorption. A method of separation whereby a fluid is dissolved by another fluid. We call it solid absorbent. Next one is adsorption. This is when atoms, ions adhere to the surface. You remove them by letting the atoms and ions adhere to the surface. That's just adsorption. Electrode deposition. You want to purify something like gold, and you make one material the electrode and make the other material the anode, so that the material you are purifying, you deposit it on the cathode and on the anode and leave the other one there. Is used in electrolysis, and we can just call it electrode deposition. Then distillation. If you go to the refinery, we have simple distillation and we have what? Complex or compound distillation. Let me give you a local example. Our parents in the village produce alcohol, ethyl alcohol, which we local call in our local parlance kai kai. And you can produce this by storing palm wine for 2 or 3 days. And you now start heating the palm wine. As you heat the palm wine, at a temperature of 78 degrees, alcohol will evaporate and boil out. And you collect the vapor. When it condenses, it becomes what? The alcohol or the kai kai we drink. That is distillation. And that is simple what? Distillation. What are you exactly doing? These two liquids, the stock palm wine you are putting there is a mixture of different materials, alcohol and water. So when you start boiling them, if you reach temperature where alcohol will boil off, it will separate, and water will what? Remain, because water boils up at 100 degrees. Therefore, it's a method of separation of different fractions of a liquid by taking advantage of differences in what? Boiling points. You will take advantage of what? Differences in their what? Boiling point. The one that boils first will go on, the one that boils second. But when you come to compound or complex distillation, if you go to the refineries, our crude oil is a mix of petroleum, kerosene, cooking gas, asphalt, wax, so many materials make up what? Crude oil. So if you go to the refineries, they have a distillating chamber. So what that distillating chamber is that they have a very tall tank called distillating. They will pour the entire crude oil into that distillating chamber. At a particular temperature, cooking gas will come out. At another temperature, petrol will come out. At another temperature, kerosene will come out. At another temperature, gas will come out. At another temperature, diesel will come out until you get down to the last one, asphalt. Therefore, you are separating this mixture by taking advantage of differences in their what? Boiling point. That is what? Distillation. Then chromatography. This is a method of separating of mixtures by taking advantage of their relative rates of motion over an absorbent medium. The materials move at different what? Rates over an absorbent what? Medium. And that method of separating is what we call chromatography. We have paper chromatography. We have different types of chromatography processes. Then sublimation is still a method of separation of mixtures. But like this one is separating a material that moves, changes from solid to vapor from a mixture. Take for instance, you have a basin of rice and someone come and put camphor into it. I know camphor and the rice are not the same thing. And the camphor has so many pieces that if you start picking them together, the color will resemble, you may not pick them. What you do is to keep them under the sun. As the sun comes, at a particular temperature, camphor will change directly from solid to gas. You know, most material will change from first to solid to liquid and to gas. But something like camphor will change straight from what? Solid to gas. And it leaves the other material alone. That's the method of what? Sublimation. You also have magnetization. If you have iron fillings, and you mix it with powder or gari, the only way to separate the iron fillings from the gari is get a magnet, place it lower to the basin of the mixture. The iron will come up and get attracted to the magnet. And that method is what? Magnetization. Then decantation. You want a lot of palm oil on top of a gallon of water. You have palm oil, you have water. Palm oil is less dense. It will float on the surface of the water. Water will be what? Denser. Water will be below. So by simply bending the container, oil will be flowing out. Just before the first drop of water comes, you turn the container up. That method is what? Decantation. You are taking advantage of a method of separating two immiscible what? Liquids. The two liquids cannot do what? Mix. And that's a method of decantation. Then you also have evaporation. Yes. You go to a salt water and you get water from there. And you start heating the water. At a particular temperature, water will boil off and salt will do what? Remain. If you go to Abakaliki Salt Lake, that is a simple way that villagers even extract salt from the salt water there. Then we have different chemical analysis. We have three major types of chemical analysis. We have qualitative analysis, we have quantitative analysis, and we have physicochemical measurement analysis. Qualitative analysis is actual determination of real constituents of a given sample material without regard to quantity. You determine the real constituents of a given sample material without regard to what? Quantity. You are just looking at what? The constituents. But you are not interested in the quantity of the what? Constituents. Then but quantitative analysis, determination of the actual amount of the constituent of a substance. This one you will determine maybe let's say sodium chloride, for instance. This is sodium and this chloride. So quantitative analysis will tell you that it is sodium that is there and it is chlorine that is there. That is qualitative. But in quantitative, if you tell you that this one is 5 grams and they tell you that this one is 10 grams, does that make sense? So why this one talks about quality? The constituent, this one calls for quantity. So both of them are used in chemistry. Then physicochemical analysis is a measurement of some physical and chemical properties of a sample. Measurement of what? Some physical and chemical properties. In some of your projects in ND program, you can be asked to measure the physical-chemical qualities of water. You are measuring the physical properties and the chemical what? Properties. Then, how do we transfer liquids with a pipette? We measure that some of the glassware include beakers, test tubes, pipettes, measuring cylinders, etc. But one instrument that is normally used in chemistry to transfer liquid from one point to the other is what? Pipette. I want to tell you how you can transfer liquids using what? Pipettes. The first is you rinse the pipette in detergent water several times. Several what? Times. 2 or 3. Even if you make it 4 times, it's still okay, so that it will be cleaner. Then you suck the liquid into the pipette until you go above the 2 cm calibration mark. Then you remove the pipette from the sample and cover the open end. Why you cover the open end? To apply pressure so that the liquid will not drop off. With that pressure covered, you now take it to where you are transferring it to. Use filter paper to clean any droplets on the pipette. And by the time you remove that forefinger you are covering at the top, the liquid will quietly drain into the container, like bottom flask or round bottom flask. And then after draining it, you just knock the pipette on the glass to remove the last droplets, and you quietly remove the pipette. While you are removing quietly, if you remove shaking them, some grease will enter into the sample. These are some of the basic ways of transferring liquid, and these are some of the basic laboratory methods and techniques we can meet in what? Chemistry. As you go further in your studies, you meet other complex methods. However, we'll still, before we conclude the lecture, look at the different glasswares you can meet in chemistry, their uses and areas where they can be used. If you are thrilled by this lecture, as we say, click on the subscribe button to join us in our part 3 and part 4 lectures, where we'll be dealing with physics techniques. Thank you and God bless you.